Okay, today's lesson is 3.1 parallel lines and transversals. So our I can statement for today is I can identify relationships between two lines or two planes, and I can name angles pairs formed by parallel lines and transversals. All right, so some vocabulary we're going to see in this lesson. Parallel lines, skew lines, parallel planes, and transversal. These are all going to be vocabulary words that you could see on a chapter quiz or test, so we want to make sure we remember what these are. First thing up, parallel lines here. Parallel lines are coplanar lines that do not intersect. So I know we've talked about this before, but some new symbols here for us to notice. You guys see these pink or purple arrows here. Anytime you see those on a line, that means that these two lines are parallel, which means they will never intersect. So, for example, if you saw something like this, we got two arrows here on here. That would tell us that these are parallel lines and that they do not intersect. So notice they are coplanar. That's the biggest part of this definition here, is that they are coplanar lines that do not intersect. Now, moving on to skew lines. Skew lines are lines that do not intersect, but the only difference between parallel lines and skew lines is that skew lines are non-coplanar. So if you remember from chapter 1, coplanar means they are on the same plane. Non-coplanar would mean that they are not on the same plane. So skew lines are going to be lines that are on two different planes that do not intersect. If you look at line L and line M here and plane A and plane B, you can see how these are two different planes and these lines will never intersect. So instead of saying that they are parallel because they don't intersect, we would say that these are skew because they don't intersect and they are non-coplanar. All right, parallel planes here. Parallel planes are planes that do not intersect. So we don't deal with this as much, but there will be times where you have skew or parallel planes. So if you look at plane A and plane B here, as you can see, one is directly over top of the other. They're not intersecting, but they are parallel. They never will intersect. So if you think of, let's say, for example, if you think of a cube. So if we had a cube right here, um, obviously the top plane and the bottom plane do not ever touch each other. So this top part here and this bottom part, these are two different planes that will never intersect. Therefore, these would also be an example of parallel planes. So let's get an example here. First off, name all segments parallel to BC. So I'm going to outline BC for us here. So BC is this line here that goes straight up and down. We're looking for anything that's parallel to it. So something else that's going to also go straight up and down and never intersect. So really anything that we see that goes from side to side or anything that intersects is not going to be parallel. So for example, we won't have anything that is parallel that includes a B or a C, because if it included a B or a C, that would mean that they are intersecting because those lines would run straight into them. So for example here, AB, as you can see, AB runs straight into B. So anything that's got a B or a C in it should not be on this list. So let's go ahead and look at it. Looks like some other lines here that are going straight up and down would be AD. Another one here would be HE. And the last one here would be FG. So as you can see here, hopefully all three of these lines go straight up and down with our CB. Therefore, they will be parallel to our segment BC. Next one here, naming some skew segments. So some skew segments. So likewise, skew segments are lines that will never intersect that are non-coplanar. So the big thing we need to remember here again is for our segment EH, anything that includes an H or an E in it, any segment that has an H or an E in it would not work out for this question, because anytime that it includes either of those letters, that would mean they are intersecting. So again, for example, FE, you can see how FE runs right into EH because those would both have an E in them. So anytime we see those two letters, We want to stay away from them unless we're talking about intersection. So some skew segments here. So I'm going to look at some lines here that are not parallel because we just listed the parallel ones. So AD, BC, FG. We've just listed those three, so we're going to want to stay away from those because we know that those are parallel. Hopefully you can see here how this AB is going to run completely in an opposite direction of EH. And you can see how these are non-coplanar. Okay, this EH here is on this left face. AB here would be on this front face. So we could say AB. We could also say DC. DC would be non-coplanar as well as skew. Also over here, CF would work. CF as well as BG. And it really looks like that's going to be it for us. If we did GH here, as you can see, GH would run into our segment EH, which would be an intersection, which we're not looking for that. So I believe here, after we get done with BG, there are going to be no skew segments left to name. So AB, DC, CF, and BG are going to be our answers for this one. All right, name a plane parallel to plane ABG. ABG. So I'm going to go ahead and outline ABG here. ABG would be this entire plane here, which is our bottom face. Okay, so our bottom face here. So we need to name the plane that is parallel to this green box, and we kind of already talked about this. When we have two planes that are in a cube, like in this scenario, the top face and the bottom face, they never intersect, and they are parallel. So as you can see here, this top plane and this bottom plane will never intersect. So we could say plane DCF. Plane DCF. All right, number 9 here. Ninth slide. We got name a plane that is parallel to plane RST. So I'm going to go ahead and outline RST here. That would be, again, the top plane. Okay, so that would be this top plane again. So really nothing changes from last question to this question. We have a rectangular prism. So the top face here is going to be parallel to the bottom face. So our answer here could be plane WZY. You could actually have multiple different names for this. Anything that includes 3 of the 4 letters on the bottom plane would count for this. So let's say, since they said RST, let's say XYZ. Plane XYZ. All right, now here, name a segment that intersects YZ. So YZ appears to be this line. We will be able to name several of these, okay? So we've talked about it in the previous examples. Anything that has a Y or a Z in it will intersect both of these segments. Well, I guess just this one segment, but both of these points. So YZ is this segment here. Anything that has a Y or a Z in it will intersect it. So for example, we could say line TZ. So TZ, WZ. Also SY. SY and XY. Okay, so as you can see, all 4 of these segments have at least one of the letters here of our original segment. So our original segment was segment YZ. All 4 lines that we chose that intersect this line include either a Z or a Y. So make sure you're paying attention to that. That will be extremely helpful, especially for later assignments. That will be a good trick you can use to figure out what it means for two lines to intersect. Now, next question here is name a segment parallel to segment RX. So RX is right here. It goes straight up and down. So go ahead. I want you to try to come up with an example here for a segment that is parallel to RX. I'll give you a few seconds here, and then I will come up with a few for you. Okay, so parallel to RX. So if you remember, parallel means they will never intersect and they are coplanar. So we're going to want to choose some coplanar lines here. My first example would be QW. So QW is coplanar as well as SY. So both of these would have worked. You could have also said TZ. TZ would have also worked. So let's go ahead and write those down. You could have either said QW, TZ, or you could have said SY. And of course, if you had these two letters reversed, those mean the same thing. So WQ, ZT, or YS would also have worked. All right, moving on here, transversal angle pair relationships. This is arguably the most important part of this lesson. So I want everybody to pay very close attention. This is something that we're going to use the entire year. So this is extremely, extremely important. All right, so starting off here, we're going to start it off pretty easy. Interior angles, I know this is a surprise to nobody. They lie on the inside of your lines. So here you can see we have line Q, we have line R. All the interior angles are going to lie within those two lines. All the exterior angles are going to lie on the outside of those lines. So outside of Q and R would be considered the exterior, while inside of them would be considered the interior. Consecutive interior angles. So I want us to figure out what these are before we even try to put a definition on them. Consecutive interior angles are exactly what they sound like. Those are two angles that are on the inside that are right next to each other, essentially just both consecutively on the inside. So our examples here, 4, and what is consecutive with 4? It would be 5, okay? 4 and 5, as you can see, they're both on the inside, and the biggest thing here is they're on the same side of our transversal here, which is T, okay? So our transversal here, which is T. So we have line Q, we have line R, we have this transversal here that goes through both of them. So when you think of a transversal, just think of it as a line that goes through two lines. So consecutive angles 4 and 5, we would have another example of consecutive angles here, which would be 3 and 6. So consecutive angles are interior angles that lie on the same side of the transversal. So both inside, both on the same side of the transversal. Next one, alternate interior. Okay, alternate interior. Those are going to be both on the inside, right? Because interior means inside. But these are going to be on opposite sides of the transversal. So much like our consecutive interior angles, the only difference is that these are on the opposite sides of the transversal. So we know they're both on the inside. We're going to skip across the transversal, and those will be alternate interior angles. You probably have already heard of these. Our first example would be 4 and 6. Our other example here would be 3 and 5. As you can see, 3 and 5 both on the interior, but they are just on opposite sides here of that transversal. So that's alternate interior. Alternate exterior, basically the same thing. The only difference is the word exterior. Okay, so alternate interior, alternate exterior, those are going to be angles that are on opposite sides of the transversal. Exterior angles are on the outside. So angle 1, angle 7 here, you can see both of them are on the outside. And we have this transversal here. They're on opposite sides of that transversal. Likewise, for 2, and if we come to the other outside here, go across the transversal, 2 and 8. 2 and 8 would also be alternate exterior angles. Now, corresponding angles, okay? Corresponding angles. So, corresponding is a little bit fancier than the rest of these because these first three here were really straightforward. Corresponding gets a little dicey here. We got one on the inside and we got one on the outside. So, our first example here would be 1 and 5. That one of them is on the outside, one of them is on the inside, but they are on the same side of this transversal here. Okay, they're on the same side of this transversal. So 1 and 5 would be considered corresponding, as well as 2 and 6. Both of those are on the same side of the transversal. One of them is inside, one of them is outside. Same goes for 8 and 4. Okay, 8 and 4 would also be corresponding. Lastly, here we have 7 and 3. Those would be our last pair of corresponding angles. So make sure this makes sense to you. If you have questions on this, send me an email. This is super, super important because we're going to be using these for the entire year. So let's do some examples for them. First example here, classify the relationship between angle 2 and angle 6. So angle 2 is right here on the inside. Angle 6 is on the outside. And I want to ask you, if C is our transversal, are these on the same side of the transversal or opposite sides of the transversal? And our answer here is going to be 2 is on the inside, 6 is on the outside. They're both on the same side of the transversal. So these are going to be corresponding angles. Okay, apologize for my pen here. It's not doing too well. So we got corresponding angles for the last one. Let's check out this one. We got angle 1, and angle 7. So angle 1 here looks like it's on the outside. Angle 7 also on the outside. C is our transversal. So they are on opposite sides of the transversal. And they are both on the outside. So anytime that we have two angles that are on the outside, I'm going to kind of think in the exterior area. And this alternate here tells us that they are on different sides of the transversal. So our answer for this example would be alternate exterior. Okay. Let's move on here. Next slide. Classify the relationship between angle 3 and angle 8. Angle 3 and angle 8. So angle 3 appears to be on the inside. Angle 8 also appears to be on the inside. So right off the bat here, we know this is going to be something interior if both of them are on the inside of our lines here. So is this going to be alternate interior or consecutive interior is the question. Remember, alternate means that they are on opposite sides of the transversal. Consecutive means that they're on the same side. So 3 and 8 here, are these on the same side of our transversal or are they on opposite sides? The answer to that would be they are on the same side of the transversal. So these are going to be consecutive interior angles. I really apologize. I do not know why this is lagging the way that it is. So these are consecutive interior. Next one here. Angle 3, angle 5. Angle 3 and angle 5. So angle 3, it's on the interior. Angle 5, also on the interior. So we know it's going to be something that involves interior angles. Now, alternate means opposite sides of the transversal. Consecutive means they are on the same side. As we can see here, 3 and 5, since C is our transversal, that's the line that goes through two lines. they're on opposite sides, that tells us these are going to be alternate interior angles. This is pretty tough. I don't know why it's doing that. All right, let's make it a little bit more challenging here. We got 3 lines. So we have 3 lines here. P is our transversal. So think of P as the line that's going through 2 or more lines here. L, M, and N are going to be the lines we're looking at. And P is our transversal. So 4 and 5 here. 4 and 5. So we're talking about angle 4. We're talking about angle 5. I want to ask you which 2 lines here are angle 4 and angle 5 on. Hopefully you said M and N. So we're going to look at M and N as our 2 lines where we consider interior and exterior. So everything that is outside of M and N is going to be exterior. Everything that's on the inside of these 2 lines will be the interior. So our red here is interior, our blue is exterior. So 4 and 5 both appear to be interior, and now we just have to figure out here whether these are alternate or consecutive. So I'll say it again, alternate, opposite sides of our transversal. Consecutive would be the same side. As you can see, since P is our transversal, 4 and 5 are going to be consecutive interior angles. Next up, 7 and 9. 7 and 9. So here's 7, here's 9. So again, just like the last question, we're going to treat L and M as our lines that determine interior and exterior. So everything in between L and M will be our interior. Everything outside of L and M will be our exterior. So 7 and 9 here. 7 appears to be on the exterior. 9 appears to be on the interior. So there's only one choice where we have an angle on the exterior and an angle on the interior. And as long as these are on the same side of our transversal, which they are, these will be corresponding angles. So choice C. All right, I want you guys to quiz yourself here, so go ahead and pause this and give this a shot. We have angle 7 and angle 4. Okay, for this one, we're looking at L, we're looking at M. I'm not going to draw our lines this time. Just know everything in between L and M is interior. Everything outside of L and M is exterior. These 2 angles here, angle 4 and angle 7, appear to be on the exterior. So we have one option, really. Since both of these are on the exterior and since they're on opposite sides of our transversal, these are going to be alternate exterior angles. Go ahead and pause this one as well. Do an example here. 2 and 11. 2 and 11. So I am going to draw our lines here. We're looking at angle L. We are looking at line L and line N. So everything in between L and N is inside. Everything on the outside of L and N would be the exterior. So I will shade in the exterior here. So for angle 2 and angle 11, as you can see, these are both on the interior. So since they're on the interior, we have 2 options, alternate interior or consecutive interior. And the question is, are these on the same side of the transversal or are these on different sides of the transversal? As you can see, since P is our transversal, these are on opposite sides. So this will be alternate interior. 22 here, we're almost done. Just a few more examples. 22, it says the driveways at a bus station are shown. Identify the transversal connecting angle 1 and angle 2. Then classify the relationship between the pair of angles. So if this is angle 1 and this is angle 2. Angle 1 and angle 2. We got to classify the relationship between the pair of angles. Now, I would say here that our transversal is line X. Okay, line X. And we want to know here, what is angle 1 and angle 2? What kind of angle relationship is that? So when I draw it out here, it makes it look a little bit easier. Looks like we have one angle that is on the outside. We have one angle here that is on the inside. So since that's the case, there is only one possibility where we have an angle on the outside and an angle on the inside. That possibility is corresponding. So these are corresponding angles. Okay. Now, same question here for angle 2 and angle 3. So I'm going to put a different color here. Angle 3. If we're looking at angle 2 and angle 3 again, we can look at line V and line X. So again, line X is our transversal here. If this was another line right here, we would actually look at line V as the transversal here with line S going on. So angle 3 and angle 2 looks like both of these are on the inside of line X and line S. So 3 and 2 would either be alternate interior or consecutive interior. So since line V is our transversal here, we would say that these are on opposite sides of the transversal. So these would be alternate interior angles. I'm going to abbreviate because my pen is giving me so many problems. All right, hang in there. We got a few more here. 24. This is slide 24. We are connecting angle 4 and angle 5. So angle 4 and angle 5. So it looks like our two lines here are going to be W and T. W and T, and our transversal that connects both of these lines here would be line Y. Okay, line Y. So we've got angle 4, we have angle 5. If line Y is our transversal, and line W and line T here are our two lines here. It looks like everything out here is going to be exterior. Everything in between these red lines is going to be interior. Angle 4 and angle 5 appear to both be on the inside. So we're going to look and check and see where they are with our transversal. So line Y here is our transversal. 4 and 5 appear to be on the same side of line Y. So that tells us here that they will be consecutive. My goodness. Consecutive interior. Okay. Moving on here. Group of nature trails is shown. Identify the sets of lines to which A is the transversal. So what line here makes A transversal? We need to at least list two lines. So remember, the transversal is the line that goes through two or more lines. Looks like our only option here, A will intersect through C, and A will intersect through F. So the only two lines that we could say for this would be lines C and F, which is option A. Group of nature trails is shown. Identify sets of lines to which B is a transversal. So B would be this line here that runs through. So we have a couple of options here. So as you can see, B runs through line C, it runs through line F, and it runs through line E. And it also runs through line D. It also runs through line D. So our answer here, since it runs through all four of those lines, is going to be C. C, D, E, and F. Last one. Identify the set of lines to which line C is a transversal. So line C runs horizontal here, and line C is going to run through a good bit of lines here. It's going to run through line A. It runs through line D. It runs through line B. And as you can see here, this is going to run through, if these lines were to extend forever and ever, which they will, you can see these will also intersect line C at some point. Okay, so since all of these lines here will intersect with line C, we can say that line C is a transversal for all of these lines. So A, B, D, E, and F. Transversal C cuts through all of them eventually. So our answer here will be B. Okay, hope this helps. If you guys have any questions, feel free to